It's a question, it's one nobody ever wants to have to ask. You see it in the news, an athlete right in the prime of their life, full of energy, and then suddenly the collapse. No warning at all. It's shocking, right? So, how is that even possible? Well, let's get into it.
Okay, so there's a name for this. It's called sudden cardiac death in the young, or SCDY for short. And the scariest thing about it? It often hits with absolutely zero warning signs. No symptoms, nothing. So today we're going to unpack the three main, kind of hidden reasons this happens. All right, first up, let's talk about the heart's structure. Think of it like the engine of a car. Sometimes the problem is a physical, mechanical flaw, one that can develop totally silently over years. Okay, get this. The single biggest cause of SCDY is a condition that affects a pretty staggering number of people. About 1 in every 500 adults in the US. And here's the kicker. Most of them have no idea they have it. It's called hypertrophic cardiomyopathy, or just HCM. So HCM is a genetic thing, and what it does is it makes the heart muscle grow way too thick. A pretty good way to picture it is like a bodybuilder who only ever works out one muscle, right? Well, in this case, that muscle is the wall that separates the heart's lower chambers, the ventricles. So why is a thicker heart muscle so dangerous? I mean, shouldn't stronger be better? Well, no. For one, that overgrown wall can literally act like a roadblock, physically blocking blood from getting pumped out to the rest of your body. It can also mess with the nearby mitral valve, making it leak. But here's the most critical part. All that physical stress on the heart can completely disrupt its delicate electrical system, and that can trigger a totally lethal rhythm.
Okay, but here's where it gets even more mysterious. What if the heart's engine, its physical structure, looks perfectly normal, even after an autopsy? That's when we have to dig a little deeper. And that brings us to the second major cause, these invisible faults in the heart's electrical wiring.
Yeah, these conditions have a name. They're called channelopathies. Basically, they're genetic glitches in the tiny channels that control all the electrical impulses in the heart. So the heart muscle itself is totally fine, but the signals telling it when to beat and how to beat, well, they're dangerously broken.
And that's the thing. If you just looked at one of these hearts, you'd think it was perfect. But an ECG, which is what reads the heart's electrical activity, can spot the hidden danger. For example, you've got the Brugada sign, and then there's the telltale pattern of what's called long QT syndrome, two different electrical fingerprints for disaster.
So let's break down a couple of the most common ones. You've got long QT syndrome. With that, the heart just takes too long to, electrically recharge after a beat. And that extra downtime creates this really vulnerable window where a chaotic, deadly rhythm can just take over. Then there's something called Wolff-Parkinson-White. In that case, there's an extra electrical pathway, basically a shortcut, that can make the heart just start racing at incredibly dangerous speeds.
And this is what's truly mind-boggling. In up to 5% of these sudden cardiac deaths, they find nothing, no trace. The heart looks perfectly normal. The only possible explanation is a fatal glitch in the electrical system. And that's what experts have started calling sudden arrhythmia death syndrome, or SADS. All right, so we've covered physical flaws with the engine, and we've covered faulty wiring. But there's a third category. And honestly, this one might be the most shocking of all, because it can happen to someone with a perfectly healthy heart, no pre-existing conditions, nothing. It's called commotio cordis, and what this is a cardiac arrest that's triggered by a direct, blunt hit to the chest. We're talking a baseball, a hockey puck, even a fist, hitting the chest at the exact wrong microsecond. And to be clear, the heart is totally normal, structurally, electrically, everything, right up until that moment of impact. For this to happen, it's like a lightning strike of bad luck. The impact has to be right over the heart. And this is the crazy part. It has to land during this tiny, minuscule window of the cardiac cycle. We're talking just 10 to 20 milliseconds long, right as the heart's lower chambers are resetting for the next beat. If both of those things happen, that physical blow instantly triggers a chaotic electrical storm called ventricular fibrillation, and the heart just stops. Now, we usually hear about this in sports, where there are hard projectiles, right? Baseball, hockey, lacrosse. But it's really not just limited to the sports field. It's been seen in combat sports, in car accidents, and even just from simple everyday accidents during playtime. Okay, so when you hear about all these hidden dangers, it's easy to feel a little overwhelmed, a little
helpless even. But we're not. So the big question is, what can we actually do about this? How can we protect young people?
Well, the first line of defense is being proactive. It's all about screening. And for those hidden structural and electrical problems we talked about, the biggest clues are often not in the person themselves, but hiding in their family tree.
So the Mayo Clinic actually recommends that every young person, and not just athletes, everyone, should be asked 4 really simple questions. They're designed to screen for personal symptoms, like fainting during exercise, and also to check for any family history of early or unexplained death.
Now, getting a yes to any of these doesn't automatically mean there's a problem. It's not a diagnosis. But what it is a huge red flag. It means it's time to talk to a doctor and probably get a referral to a specialist, a pediatric cardiologist, who can do more tests, like that ECG we mentioned. But look, screening isn't a silver bullet. It can't catch everything, especially something as random and unpredictable as commotio cordis. And that's where our second toolkit comes in: emergency response. Because when someone goes into cardiac arrest, every single second counts. We're talking the difference between life and death. Just look at these numbers for commotio cordis. If you can get an AED on that person and deliver a shock, but it takes more than 3 minutes, the survival rate is only about 25%. But if you get that shock delivered in under 3 minutes, the survival rate shoots up to over 70%. The clock is literally everything.
This right here is called the chain of survival. It's a really simple but incredibly powerful set of steps. First, you have to recognize what's happening. Then, call emergency services. Immediately start CPR to keep blood moving. And then, as soon as you can, use an AED to try and shock the heart back to a normal rhythm. Every single link in that chain is absolutely critical.
So, what's the big takeaway here? Well, the causes of sudden cardiac death in the young are definitely complex, and they're often totally hidden from view. But if we combine smart screening with a plan for rapid emergency response, we can build a really powerful defense. The point is, we are not helpless against this.
And that leaves us with one last really important question for you to think about. Think about the schools, the sports fields, the gyms in your own community. Do you know if they have AEDs? And are the people there, the coaches, the teachers, even the parents, are they trained in CPR? To put it simply, is your community prepared